Hi everyone, welcome. We are so excited to have you here as you start your journey towards New York City Specialized High School Admissions Test SHSAT. In this video, we're covering a math lesson to build the foundation you'll be needing to get a top score. Before we begin, be sure to have a pen and notebook ready with you because we'll be talking about many tips and strategies throughout, so make sure that you do have all of the necessary equipments so that you can note down anything that you find important. Also, if you cannot afford expensive tuitions, don't worry. Our free lessons and practices are more than enough to help you prepare completely for your exam. Plus, our app also offers a predictive test, which is going to give you a realistic feel of what the exam is going to feel like. Now, let's get started and take the first step towards landing into one of New York City's specialized high schools. So like I said before, if you would want more practice materials, make sure to download our SHSAT Prep app from Apple App Store, where you are going to find lots of different practice materials so that you do not need expensive tutoring anymore. Without any further ado, let's get ahead with the video. So in this particular lesson, we're going through fractions. As we can see, equivalent fractions, reciprocal, how to compare between fractions, and at the same time, we're going to go through addition, subtraction, multiplication, and division related to fractions. So let's start. First of all, what is the simplest equivalent fraction of 36 over 64? What the question says is basically we need to simplify 36 over 64 to the shortest possible form, okay? So our basic instinct is going to be, because these both are even numbers, we can divide it using 2. But let's go for some bigger numbers. If we look at 4, can we divide both of these by 4? I know if you remember the basic, times table, if we divide 36 with 4 and 64 with 4, if we divide 36 with 4, that gives us 9, because 9 4s are 36, 9 times 4 is 36. How about 64 over 4? You can do a simple calculation right here. 4 times 1 is 4, which gives us 2 and 4, so that gives me 6, so 4 times 6 is 24, right? So that makes it 16. So it's 9 over 16. If you consider, are there any numbers that divides 9 and 16? Let's say 3. 3 times 3 is 9, but 3 times 5 is 15, not 16. Which means that this is the simplest equivalent fraction of the fraction that's already given. Got it? Let's now move on to the next question. Write 3 equivalent fractions of 3 over 7. Okay, this time the answer is given, yeah? If we simplify, the answer is already given, so we are supposed to find out the numbers that we get after we multiply. So we have to do it the other way around. So if we look at 3 over 7, and if we want to know 3 other fractions, what we can do is, basically, we can multiply 3 and 7 with the exact same numbers. So for the first fraction, let me just multiply it with 2. For the next one, I am multiplying them with 3. For the next one, I am multiplying them with 4. So 3 times 2 is 6, 14, 9, 21, 12, 28. Okay, so there you have it. These are the 3 equivalent fractions of 3 over 7. If you're unsure that whether or not my answers are correct here, what you can do is you can go back and you can simplify these and check if you all end up with 3 over 7 for all 3 of them, okay? So that's basically how it works. Let's move on to the next question. What is the reciprocal over this? Okay, so first of all, what does reciprocal mean? Reciprocal means any particular fraction where we are going to do 1 over the entire number or the entire fraction. I'm just writing number because that's what reciprocal means. It's 1 over the entire thing. So first of all, because we have 3, 5, and 7, we need to convert from a mixed number to an improper fraction. How do we do that? To do that, we need to multiply 7 times 3 first. So we need to do 7 times 3 first, then you add it with the numerator, and you keep the divisor as it is. So that means 7 times 3 is 21, 21 and 5 is 26 over 7. That's my first step. And for the next step, it's what? It's 1 over the entire number. It's basically 1 over 26 over 7. And if I want to make it easier for you guys, if you just want to make it the reciprocal, just flip it. Make the denominator the numerator, then the numerator the denominator. So my final answer to this is 7 over 26. Quite easy, right? Let's move on to the next question. Okay. Here we see what is the reciprocal of 0.6. So if we have a decimal like this, what do we do? First of all, the first thing that we do need to know is how to convert this decimal to a fraction. How many numbers do you have right next to the decimal point? 1, right? This means that whatever numerator that you do get, it needs to be divided by 10 if you want to remove the decimal point. Had it been 0.65, in the denominator, you would have written 100, okay? So that's how it works. And now in the numerator, because the decimal is now removed, if you remove the point from 0.6, you only end up with 6. You also have a 0 up front, but we know 0.2, 0.6, 0.3, they all mean the same. It's just 2. 0.2 is just 2. So 0.6 is just 6. Now what? Now if you want to know the reciprocal of this, what you can do is you can actually flip it. So if you flip it, that becomes 10 over 6. But you can actually keep your answer in this way. But what we do recommend is giving your answer in the shortest possible format. By that I mean you can actually simplify this on your own, right? So by simplification, you can do 2 times 5 and 2 times 3. So that gives me 5 over 3. You can keep your answer like this, or you can convert it to a mixed number. So you can do this. So that's 3 times 1. And do you remember the format for the mixed number? This is the quotient over here. This is the remainder, and this is the divisor. So the format is, you need to write in this form, Q R over D, which means what? The quotient here is 1, remainder is 2, and the divisor here is 3. So you can also keep your answer like this. You can also keep your answer and make it into a decimal point. So how do you do that? So if you want to turn it to a decimal point, you need to continue your division in this case. So what you can do is you can actually put a decimal right here. It's going to be a 20, right? And now we need to see that what goes 3 with 20. 3 times 6 is 18. Subtracting that gives you 2. Because of the decimal is again a 2. It's again a 0. 3 times 6, 20. So you do understand that it's just going to go on and on and on. So my answer here is 1.66666. So if you want to round it off, because there are so many 6s, the end digit, of course, is going to be a 6. So if you round it off, because 6 is more than 4, the previous digit needs to be added to 1, right? So my answer to this can be also 1.67. This means that there are 3 answers to this. This is the first one. This is the second one. This is the third one. Either of these are fine. There's another sort of answer, by the way, because as you can see here, the numbers are going on and on and on, 1.66666, and so on. You can also say that this is a recurring decimal. A recurring decimal is basically a number that continues. So you can put a 1 and a point and a 6 and put that recurring mark right there, which indicates that the 6 is going to go on and on and on. Got it? So did you understand how I got the same answer in 4 different formats? That's how you can actually put your answer. Okay. Let's now look at a practice question. So practice questions are there so that you can practice them on your own. You can take a screenshot of this or write this down on your notebook. And then once you're done with this, make sure to check your answers. And I hope that you do get these ones correctly, okay? Let's now move on to the next question. Okay. Now we have another question where we have consecutive integers. If you don't know what these are, consecutive integers mean numbers that go right next to the other. So for example, if you have 1, the consecutive integer for that is 2. 10, it's 11, then it's 12, and so on. So between which 2 consecutive integers is the fraction 108 over 7? Which means that, first of all, you do need to understand what does 108 over 7 really mean. To do that, I need to do a short division. So let's do that. 7 times 1 is 7. That gives me a 38. 7 times 5 is 35. That once again gives me a 3. If you do want to continue, you can put a decimal. It's going to be a 0. So 7 times 4 is 28. That's a 2. Then again, if there's a 0 because of the decimals, then you can do 7 times 2, which is 14. And I hope you do get it, that your answer is going to continue. So if I want to round it off, it's 15.4, or because the number here is 4, it's not greater than 4. If it had been greater than 4, if I did want to round it up, it would have been 16. If it would have been 15.5, 15.6, all the way to 15.9, the number would have rounded up to 16. But because it's 15.4 here, we will be rounding it off to only and only 15. What that means is, here is 15, and again, here is 16, and right in between, we have 15.4. Or in other words, we have this, right? So again, the question is, between which two consecutive integers is this fraction? Which means that my correct answer to this is 15 and 16. Hope you got this one right as well, okay? Kind of easy, right? If you do get the concepts clearly, I think it's easy for all of you to do maths. Let's now look at the next question. Find a fraction between 2 over 3 and 3 over 4. So this time we don't have an integer, we have a fraction to think about. So first of all, we need to make both 2 and 3 and 3 and 4 into equivalent fractions. By that, what we need to know is we need to have the same denominator, okay? How do we do that? Let's look at 2 over 3. Let's look at 3 over 4. And now let's see what is the one number with which we can multiply both of these to get the same number. The strategy can be to just multiply 3 with 4 here. So we can just multiply 3 with 4 here. And again, flip it. So we can multiply this 4 with this 3 here. Got it? Had it been 5 and 6, we would have written 5 times 6 here and 6 times 5 here. So it's basically the denominators getting multiplied to each other so that you end up with the same denominator. So that's the strategy. Now, if you, because we have figured out, we have actually brought out a new multiplication sign here. We have actually written times 3 here, which means that the numerator will also have a times 3. This also means that this numerator will have a times 4. Now, this makes us 8 over 12, and this gives us 9 over 12, right? Now, if you properly see like what's happening here, this is 8 over 12, this is 9 over 12. You can actually put this as it is and think about it in a different way. Like if you want to find the equivalent fractions, you can actually multiply it with 2 here as well. So if I do that, if I multiply everything with 2, that gives me 16 over 24. And here we have 18 over 24. So either of these really work. Now, if you see this properly, 16 over 24 and 18 over 24, right in the middle, we can have 17 over 24. But my question is, why didn't we end just here? Because we have 8 over 12 and 9 over 12. 8 and 9 go next to each other. So can we really write 8.5 over 12? We can, but once again, it's not like a complete fraction. It does not have integers over integers, right? Because we wanted that, we wanted a fresh number, which is why we multiplied all of these with 2 again, so that we end up with 17 over 24. Okay, I hope this strategy does work out for you, because it actually does. First of all, make the denominators the same. Then if you look at the answers, if the integers, go hand in hand right next to each other, how are you supposed to find the middle number, right? So all I can do is just multiply all of these with 2 once again, and then check if you do have the perfect middle number, okay? So that's the fraction between 2 over 3 and 3 over 4. I hope you did understand what I've just done. Let's now move on. It's once again another practice question. I hope you do get these ones right. And then once again, check the answer. Okay. Now comes another part where we need to add both of the fractions, as we can see. The first step here is we most definitely need to convert the numbers here to improper fractions. How do we do that? Just like I said, in the numerator parts, we need to multiply whatever we find as the quotient and the divisor. So that's going to be 3 times 8, and then add it to the remainder. So add it to 5. And 8 is going to be ending up with as 8. Once again, you do what? 5 times 12 over here, add it to 5, and then you put a 12, right, the way that we have already done. What that ends up as being is 8 times 3 is 24, and 5 adds 29 over 8. And again, plus 5 times 12 is 60. 60 plus 5 is 65 over 12. Now what? Now, because we need to make sure that both of the denominators is the same, you can take LCM. Or there's another way of doing it. You can actually try to multiply, 12 with 8 and 8 with 12. That's another way. So let me just show you how to do LCM over here because that's the easier method, okay? 8 and, okay, it's 12. I wrote 12 here. First of all, use prime numbers. So use 2. Use the shortest prime number. So if you use 2 over here, you can actually do what? 2 times 4 is 8. 2 times 6 is 12. Again, you use 2. 2 times 2 and 2 times 3. Again, you use 2. That's 1. That's 3. Finally, you're ending up with 3 because 2 doesn't go. So if you multiply all of these, that's 2, 2, 2, 2, and 3. 2 to 4. 4 times 2 is 8. 8 times 3 is what? That's 24. So what you can do now here, you can actually put a big division sign. You can write a 24 over here. And now you can, what you can do is you can try to figure out what's in between. I'm going to show you 2 methods, okay? You can try to figure out what you get when you divide 24 with 8. So dividing 24 with 8 gives us 3, and then you multiply that 3 with the numerator. So that's 29 times 3 plus, again, you divide these 2, that gives you 2, and then you multiply that to the numerator. That's 65 times 2. And then if you do these multiplications, it's going to be 87. Plus, if you do these, it's going to be 130 over 24. And that's basically option number 1 that you can do. There's another way. In this particular step, you can actually, I'm just writing it separately, you can actually try to make 8 into 24. So if you want to make 8 into 24, what do? You multiply that to 3, right? If you do that to the denominator, you also have to do it to the numerator. That's just how fractions work. Plus, again, this 12, you can actually convert it to a 24 again. So this means that you need to write 2. Once again, you are going to multiply that to 2. Now what? Now you're going to be ending up with 29 times 3 is 87. 8 times 3 is 24. Again, 65 times 2 is 130. 12 times 2 is 24. So basically, you end up in the same place, okay? It's both are the same. So whatever totally suits, whatever goes with you, you can do that. Now, just for the end part, add these 2 up. It's going to be 217 over 24. Or if you want to convert it to a mixed fraction, just like I said, if you divide it and all, it's going to be 1 over 24. Either of these are your correct answers, okay? Hope you did understand this well, and if you did, let's move on to the next question. Here we have a subtraction. Exactly the same strategy, it's just that we have a minus sign in the middle, okay? So let's do this pretty quickly. Let's see how fast we can do this, okay? 1 over 5, that's 5 times 3 is 15 plus 1 is 16, so that's 16 over 5. Minus 2 times 3 is 6, 6 plus 2 is 8, 8 over 3. Then what? Then we're supposed to find the LCM, or we're supposed to find the number that really goes with each other, right? And that's actually 15, as we can understand, because 5 and 3 is 15. So if you want to make this 15, basically you're multiplying 5 with 3 to make it 15, which means that you are also supposed to multiply 16 with 3. Minus, you want to make this 3 the 15, which means that you're doing 3 times 5 is 15, which means that you also need to do 8 times 5 over here. Now, 16 times 3 is 48, so that's 48 over 15. Minus 8 times 5 is 40, that's 40 over 15. If you want to solve this further, it's 15 right here. It's 48 minus 40 over here. That's 8, and that's 15. Okay? Pretty easy, right? So it's just the same strategy that you need to follow both for additions and subtractions whenever you're solving fractions. Now, let's look at a mix of both the additions and the subtractions, yeah? So to do that, first of all, we need to convert all of these to what? two improper numbers, remember? So let's just do that real quick. 5 times 1 is 5, 5 plus 2 is 7. So that's 7 over 5. Plus 3 times 10 is 30, 30 and 3 is 33 over 10. Plus 5 times 3 is 15, 15 plus 1 is 16 over 3. Minus 4 over 15. Okay, that's my first step. Now what? Now we're supposed to figure out how to get all of these numbers the same. And to do that, what do? We do a small LCM right here, okay? So that's 5, 10, 3, and 15. So let's start with 5, because 5 is also a prime number, right? So 5 times 1, 5 times 2, 3, 5 times 3 is 15. Now we can do with 2. 1 doesn't break 3 or 5. So now we can do with 3. 1, 5. So we only have 5 that's remaining. We do till we get all ones, yeah? So now, as you can see, the denominator, the entire value for this is going to be 5 times 2 is 10. 10 times 3 is 30. 30 times 5 is 150 because 3 times 5 is 15. So that's 150. So now you need to know how to convert all of these to 150. So that is one of the strategies that I've already shown you, yeah? That is what you can actually do. And to do that, you can write a big denominator right here. You can write 150 over here. Now you can actually divide 150 with 5. That gives me what? 5 times 3 is 15. And then there's a 0, which means that it's 30. So you do 30 times 7 over here, plus, again, 10 times 15 is going to be 150. So you do 15 times 33 over here, plus 3 times 5 is 15, so it's 50. So 50 times 16 over here, minus 15 times 10 is going to be 150. So you do 10 times 4 over here, yeah? Now what? Now separately, you're going to be writing all of these and then subtract that from that, okay? Once again, while you're doing it, you also need to properly simplify all of the things that you've been doing so far. So that's like the main strategy that you can take. This is like option number A. Let me just write it down. Let's look at option number B, okay? Because I do want you to do the math in the easiest way possible. So for the second option, what you can do is all of these denominators that you see right now, you're supposed to find out what is this like the smallest number that goes with all of these. Let's say if you want to divide 5 with what number? If you want to divide 10 with 5, that goes, right? But does 10 divide with 3? No, it doesn't. Okay, if you want to take 20 goes with 5, with 10, but does it go with 3 or 15? No, it doesn't. If you want to go with 30 goes with 5, 30 divided by 5, 30 divided by 10, 30 divided by 10, as well as 30 divided by 15. So 30 can be a number. It can be a safe number with which you can divide all of these denominators here, right? So if you want to go for 30 with all 4 of these fractions, what can you do? To do that, you can actually do 5 times 6 as 30. In the case of 10, you can write 10 times 3 as 30. In the case of 3, you can do 3 times 10 as 30. And for 15, you can do 15 times 2 as 30, okay? So this is another strategy. And in the numerators, you need to do the same. So because we have 7, we have 7 times 6. We have 33, we do 30 times 3. We have 16, we do 16 times 10. We have 4, we can do 4 times 2. Now what? Now you end up with 7 times 6, so that's 42 over 30. You end up with 99 over 30. That is 160 over 30. And finally, you have 8 over 30. Now that all of your denominators are the same, you put a big sign over here, and then you add all 3 of them, you subtract this. So if you add all 3 of them, you get 301. Let's get this straight. You do additions first, just like PEMDAS. We did PEMDAS before in school, right? So according to PEMDAS, you're supposed to do the additions first, then the subtraction. So we do all 3 of them. We add these 3 up. We get 301. You subtract 8 now. So if you subtract 8 now, you get 293 over 30. You can keep your answer like that. Or if you do want to convert it to a mixed fraction, just like it's shown in the question, it's 923 over 30. So both of these answers, as you can see here, are going to be your correct answer. Okay? Hope you got this one right. And if you did, let's move on. All right, here are some most definitely there for practice. And if you did get these correctly, here are the answers as well. Now let's move on to multiplications. Okay, multiplications and fractions are actually kind of easy because all you need to do is simplify. If you do get the simplification part correctly, that's all. For simplification, by the way, there are 3 ways you can simplify. You can simplify the numerator with the denominator. You can simplify like this. You can simplify like this, but you can never simplify the numbers that are next to each other, okay? That does not work. First of all, what we do here is we need to convert this mixed number to an improper fraction. To do that, we do 15 times 1 is 15. 15 plus 4 is 19 over 15. Now you put this the same way. Just like I've shown you before, what goes? Does 19 and 15 go? Nope. But can we go this and this? Yeah, we can. So we can simplify as 5 times 1, and we can simplify as 5 times 3 being 15. So that's 19 over 3. You can keep your answer like this, just like I've said. Or you can do a quick math like this. You can go like 3 times 6 is 18. So that gives me what? 6, 1 over 3. Either of these answers, according to this, is most definitely correct. Okay, let's move on to the next question. So here we have another multiplication where both of these are mixed numbers. No problem at all. It's just the same strategy all over again. 4 whole 3 over 5, and then 2 4 over 23. So 4 5s are 20. 20 and 3 is 23 times 2 times 23 is 46. So 46 plus 4 is 50. Now what? Very easy, right? We can simplify this 23 and 23. Just going to be 1 and 1. If you simplify this with this, it's 1 here, it's 10 here. So my final answer is a very easy 10. Okay? Let's look at any other question that we have. Yeah, we have one for practicing. Most definitely, I do hope that you do get a 15 right here. Okay, let's now learn how to do divisions. So do you remember reciprocals? We're going to go through that when we do this question, yeah? The first thing here is we need to convert 1 and 2 into an improper fraction. So to do that, we do 5 times 2 is 10, and 10 and 1 is 11. So we are going to do 11 over 2. And then just write divided by 22. So that's my first step. And now, whenever you go through divisions and fractions, the number that goes right next to the division sign needs to be the opposite, which means that we need to form a reciprocal of this. A reciprocal of this is going to be what? Just 1 over 22. And because you have actually converted this to a reciprocal, the division sign turns to a multiplication sign, okay? Because that's like the easiest way of doing divisions. Now what? Now we can just do simplifications. 11 times 1, 11 times 2. And I don't think you can divide anything because we cannot divide side by side, remember? Which means that in the numerator we have 1 and 1, so that's just 1. In the denominator we have 2 times 2, and that's just 4. Got it? So this is very easy, right? If you consider knowing simplifications properly, if you get your times table correctly, this is very easy. We have another one right here, as we can see. If we want to divide 3, 1, and 7 with 4, 4 over 21, first of all, you need to write this as what? 7 times 3 is 21. 21 and 1 is 22. So that's 22 over 7 divided by 21 times 4. It's going to be what? That's going to be 84, yeah? 84 plus 4 is 88. 88 over 21. Now what? Now, once again, just like I've said, you need to convert this division to a multiplication sign. To do that, you need to flip. You need to make it the reciprocal. Now what? If we consider 11 times table, quite easy because 11 times 2 is 22. 11 times 8 is 88. You can again go side by side because you can go 2 times 1 and 2 times 4. And here you can go 7 times 1 and 7 times 3. I don't think we are left with anything else. So in the numerator, you have 1 times 3, which is 3. Denominator, you have 1 times 4, which is 4. Okay? All right. Now, moving on to the next question, if you did understand this correctly. Yeah, we have a mixture. We have additions in the numerator and we have subtractions in the denominator. What do we do in this case? First of all, let's individually do this addition part, individually this subtraction part, then we're gonna move on to divisions, okay? So if you have individually 1 over 2 plus 2 over 3, the first thing that you do need to know is find the same number that goes with both of the denominators, which is quite easy, 6, right? Because you can do 2 times 3, which is going to be 6, so which means you also need to do 1 times 3. You can do 3 times 2, which is going to be 6, which is also going to be 2 times 2, which means that that's 3. 2 times 3 is 6. This is 4. 3 times 2 is 6. Adding them up gives you 3 and 4, 7, and that is just 6. Now let's do the denominator part. We have 2 over 3 minus 1 over 2. So you can actually, once again, change this to 6. Just like that, I am doing times 3 over here. So that gives you 4 over 6 and 3 over 6. 4 minus 3 is 1, and then you have a 6. Now what? Now you're supposed to divide this with this. So you basically have a 7 over 6 divided by 1 over 6. Like I've said, if we want to convert the division sign to a multiplication sign, it changes, right? So 1 over 6 is now going to be 6 over 1. Even if you didn't write the 1, it would have been the same. Now, if you can just simplify this with this, that just gives you a very easy answer of 7. Okay? I hope you did get this one correctly as well. Let's move on to the next question. Okay, we have a lot of practice materials here, as you can see. Most definitely check them out. I hope you do get these answers correctly. Let's look at the next question. Okay, word problems. Of course, these are very important. Let's see. Lewis has 4 pieces of copper wire as given below. 4 pieces. Lewis needs a 5 over 8 meter length of copper wire to complete a project. Which wire should he use with the least length of leftovers? Okay, so basically that's what happens when we go to a store. Let's say you need this amount of something, but the store only has packets of 5, packets of 10, packets of 16, 15, 20, and something like that. So we are most definitely going to take that packet that gives us the least amount of leftovers, or that gives us not a lot of amount of losses, right? So Lewis is actually trying to figure out the same thing. So to do that, he can actually convert all of these to decimals so that he can properly understand which number goes with what. Let's say if the numbers were quite clearly, if it had been like 2, 4, 7, and 8, and let's say Lewis needs a 5 meter. Which one would he have picked? He cannot pick a number that's lower than that. So he cannot pick 2 or 4. He would have picked 7. He cannot also pick 8, but 8 is going to give him a 3 meter loss, which he does not need. Got my point? So this is why all of these numbers should now be converted to decimals so that you do understand what their actual values are. Let's do that. So 2 over 3, if you convert that to a decimal, it's going to be what? 3 goes outside. 2 is inside. So for the very first number, you need to put a 0. So that gives me a 2. Put a decimal. It's going to be a 0 here. Now you can write 3 times 3 5 is 15. 3 times 6 is 18. Put a 0 again. So you do understand that the number is going to continue. So that's going to be 0.67. That is my first number, okay? Now, you have 4 over 5. Do the same for 4 over 5, okay? So put 5 over here, 4 over here. It's going to be a 0 here. 4 point is going to turn that to 40. So that leaves us with 0.8. Again, 7 over 9. I'm just going to write the final answer down because I hope you do understand the point. So 7 over 9 is going to be 0.778. 5 over 6 is 0.625. Also, you do need to convert that whatever is asked in that question into decimal, because how else are you going to understand what number goes with it, right? So if you do the same here, it's going to be 0.625. Now, if you see these two properly, these go completely hand in hand. So because, 5/6 is actually not 0.83, is 0.625, by the way, I made a mistake, is 0.833. You would get it if you did do the long division, yeah. So now, if you see these answers are not supposed to match, but if you look at the one that gives you the least amount of, corrections, because 5/8, you can actually take either of these lengths because all of these are bigger than this. However, this is actually giving you the least amount of difference. See, you would only have like a 0.02 or 5, something like that. So you can just keep that off. So the least length of leftovers is, as we can see, it's 0.7, or my correct answer is going to be choosing the 2/3 meters of copper wire, so that we have the least amount of leftovers. The answer overall, like I'm going to say that the process is quite lengthy, but if you do get the hang of it, if you practice a lot, most definitely whatever you are doing individually on paper is going to take a much less amount of time, because maths is all about practice. Let's look at another question. On Monday, the water was shut off 3 times for 1/4 hour, 2/3 hours, and 2/3 hours. How long was it off? Of course, because it's saying how long was it off in total, that's what it means. We need to add all of these together, okay? So if we add them, it's going to be 1/4 plus 2/3 plus, let me just convert this real quick. So it's going to be 4 times 2 is 8. 8 and 3 is 11. Now what? Now you need to convert all of these in the same way. What we can do is, you can actually do 4 times 3 as 12, 3 times 4 as 12, again 4 times 3 as 12. So that's like the easiest way. So you can do 4 times 3, 3 times 4, again 4 times 3, which means that the same goes to your numerators. Okay, now what? So that's 3/12, 8/12, 33/12. Now, if you add them, that's 33 and 3, that's 36. 36 and 8 is 44. Okay, 44/12, if you simplify it, you can simplify it using 2, right? Or you can even simplify it using 4, the biggest number. 4 times 11 is 44. 4 times 3 is 12. So your final answer can either be 11/3, or you can convert it to a mixed fraction, which is 3/2/3. Both of these answers work. I hope you did get this correctly. Word problems are just there so that they test whether or not you do understand what the question is asking. But because if you do that, then that's like half of the answer that's done, right? If a baker wants to bake, okay, it's going to be bake, you do understand. Okay. If a baker wants to bake 1/2 of a recipe that needs this amount of cups, how many cups do we really need? All right. So each cup, the recipe needs this many cups, but in total, how much do you need? It's just like 1 cup can hold 2 liters, let's say. So 5 cups can hold what? So that's 5 times 2. So same here. What we need to know here is how to do basic multiplication of this and this. If you want, I can just skip this part and I'm just going to write the answer, because we've already been going through all of these things, yeah? We have 2 more questions left, so let's look at this one. A car travels this amount of a mile in this amount of an hour. What's the average speed? So I hope you do remember the formula for average speed. For average speed, the formula is distance over time. So because the distance here is already 36, 3/4, over means what? It means division, right? So divided by 2/3. So that's basically what the question asks. So understanding what the question asks is very important. If you now do it in the basic format, convert it. So it's 147/4 divided by 2/3. We know that we need to convert this division part to a multiplication form, and then we need to simplify. If you do that, you're gonna be ending up with 441/8 or 55/1/8, and your answer is most definitely gonna be ending up at miles per hour. Okay? Last question for today. Let's go. Okay. On a design of the institute, 1/3 inch represents 30 feet. If the library is 20 feet long, what is the length? So basically, you can also say this is in mathematical terms, we call it unitary method, okay? So because we can see that 30 feet represents 1/3 inch, the first step is to figure out what does 1 feet represent. 1 feet most definitely is going to represent much smaller, because that's what architects do, right? If you want to draw this entire room, you cannot have like a page that's bigger than this room and then you draw. No, you put it into scale and then you put it in a shorter format. So if you want to look at something that's 1 feet, that's going to be shorter, and anything that's actually shorter, you divide. Anything that's bigger, you multiply, okay? So 1/3 divided by 30, that's going to be in a reciprocal form. So that's going to be 1/30. And of course, you cannot simplify anything over here, so that's just 1/90. Now, the question said, what do you get if you have 120 feet? So if 1 feet represents this, 120 feet is most definitely going to be bigger. And bigger means we multiply. So 1/90, you multiply that to the question that's already given, that's 120. Now you can simplify. You can actually cancel off these zeros first. Now you can simplify using 3. 3 times 3, 3 times 4. So that gives me 4/3 inch, or 1/3 inches. Okay? Hope you did understand this as well. And if you did, here are 2 practice materials. As you can see, here is one to figure out something related to books and Dina from a library. Make sure you do get 4/15 here. And here is another question, as you can see, figuring out the time, okay? And with that, that's the end of this video. So with that being said, that is the end of this lesson. Thank you so much for watching. And if you want more practice materials and videos like this, make sure to download our SHSAT Prep app from Apple App Store. You are going to find out a lot of practice materials, and at the same time, there's a predictive test waiting for you, so that it's going to give you a real feel of what the exam is going to feel like. Thank you so much for watching once again. Make sure to check out our next lessons, and at the same time, subscribe to our YouTube channel for more.